Okay, so I had a couple of questions that I thought were stuff I should remind you about. Okay, I have a suggestion. Should we just kind of stop with the review after we finish this problem, because this is the last of the projectile motion ones, and then take part one of the test, which is just going to be over 7.1 and 7.2.
Okay.
Come back and review 7.3 and then do the other part.
Yeah.
That sound good? So we kind of break it into smaller pieces.
Yeah.
Okay. So a question came up relating to something like this one. Okay. The question is, how do you know which angle? If this is 16.8, how do you know which angle this is? Right. So what you want to do with this is that whole principle of exaggeration thing. So make sure when you're drawing these pictures, and this is really crucial, when you draw the pictures, don't draw the pictures, even if the angle is like 44 degrees or something, right, which is close to 45. Don't draw the pictures so the angle is not obviously either really big or really small, right? So when you draw the ramp, for example, then, like there's the ramp. Even if it's 44 degrees, just make it look like it's really a shallow ramp, so this angle is small, right? And then when you draw the vectors, so there's the object, there's gravity, right? There's normal force, let's say. And I don't know, maybe we have friction, maybe we don't. But the whole point here, like in the one we did, is we've got to take gravity and break it up into components, right? So we're going to take the gravity vector and trade it for the perpendicular component and the parallel component. Well, obviously here, which of these two angles, angle 1 or angle 2, is going to be the one that's the same as theta? Angle 1, and we can tell because that's a small angle and that's a big angle, right? But it's difficult to tell if you make that thing close to 45 so they look the same, right? The pictures, physics is so much about pictures. It really is. A lot of it is about being able to, just take, and you can't, I know you guys are probably, I am too, ecologically conscientious, but making these little tiny pictures just doesn't cut it. You gotta waste some paper. You gotta make big pictures so you can kind of see the details, so it really starts to get confusing. You're gonna strain your eyes too much. Yes?
Not to change the subject, but all of my practice was gone.
Oh, for which one? 7.1?
Like, I don't have any time.
Okay, right, so what I did, I can put it back. What I did was I had to reset our class for next semester. So all the stuff from first semester, I've gotten rid of. But the 7.1s went also.
Yeah, like everything.
Okay, so I'll turn those back on. Okay, I can do that. Thank you for bringing that to my attention.
Oh, yeah, you got it.
Okay, so I'll put those back in and turn them on. I wonder why, I thought I was pretty careful about that, but obviously I wasn't. So there's that one, right? Should I do that right now, so you guys can look at those? Give me a quick second. Okay, so how about, let's look at this one real quick, and then I think maybe just get questions answered and work. So let's look at this one, the hang time question, right? Football hang time stuff. So if you kick a football, from ground level, and it leaves at an angle of 51.9 degrees relative to the ground, with an initial speed of 20.1, then this is the picture that you get, right? So we're looking at the velocities, right? The initial velocity vector is 20.1, and then what are these components going to be? Well, so that's going to be
Cosine.
Okay, cosine, and I still put the angle in there too. How about that?
Are you recording this?
I am recording this, yes. So the angle is 51.9, right? So there's my angle, so then this would be sine or cosine? Cosine, so I'll multiply the magnitude by cosine, and that's going to give us our initial vertical velocity, right? Everybody agree? So the y component, or the vertical component, would be 20.1 cosine 51.9, right?
That's horizontal, right?
Oh, you're right. That's horizontal.
It's been a long day.
It's been a really long day. So we gotta go, that's gonna be the, I got my colors even wrong. Oh, I guess they are gonna be wrong. Oh well. But that one should be, I should make that red.
Isn't that X?
It is, you're right. Okay, so let's go over here. The horizontal component is gonna be the one up here that's blue, right? I'll make it green down here. So that's gonna be 51.9
Wait, 20.
cosine, sorry, 20.1, I'm looking at the wrong number. Oh my gosh, it has really been that kind of day. 20.1 cosine 51.9 degrees. Okay, there we go. So that's the horizontal component. Let's make that green, so it looks green, right? And then over here, let's see that guy. Green. That guy looks green.
Oh, it looks way better.
Way better, huh? That guy should be blue. Now we're good, right?
There we
So
go.
vertical motion, this one's gonna be, that'll be the sign, right? So V naught sub Y equals 20.1 sine 51.9 degrees. And this one over here, I guess I should have written this. This is really just V sub X, right? Because it's not gonna change. Horizontally, we know the horizontal component for projectile motion is constant. Okay, good. What else? What are we trying to do here? So we're trying to answer some questions with this. The football has a hang time of what? Well, how are we gonna figure that out? How do we do this stuff? What's the football gonna do vertically?
You have to do, like, split it into two parts.
Split it into two parts, right? Vertically, the football, if we eliminate the horizontal motion at all it does vertically is goes up, it comes down, right? And they're symmetrical. It takes just as long to go up as it takes to come down, right? So why don't we take half of the time and just see how long it takes to get to its highest point, and then just double that to get the hang time, right? Remember, that's our little trick for this one? Okay, so we'll call this then the final, for the distance, for the trip up anyway, what's my final velocity? 0, right? So this is just for 1/2 the trip though, right? So I'll put a little asterisk out front there, right? Because we're doing just for 1/2 the trip. That's gonna be 0. And what's the acceleration vertically? Positive or negative? Negative. Okay, so we know A sub y equals negative 9.8. And so all I gotta do then is use, this is an easy one, right? Yes.
If it's going up, why is it negative? Because if it's like,
Because the acceleration is negative, right? Because if I throw something up in the air, if the acceleration were positive, that'd be weird. If I threw something up in the air, it would just accelerate upward and never come back. Right? It's accelerating.
but we're only doing the half.
You're right. You're right. But the ball has some initial, it does this, right? It's got some initial velocity upward, positive initial velocity, but it slows down. Right. There you go. So the acceleration is negative. What's going to be, which one of these are we going to use now? Don't have to be that complicated.
First one. Second one.
Second one, yeah, we get to use one of the easy ones, the second one, right? So we can use equation number 2, which is just V equals V naught plus AT, right? That's an easy one. And which one of those is 0? That's supposed to be just a, which one of those is 0?
Be not.
No.
No, B.
B, yeah, so that one is 0. So all I've got to do then is just subtract that one to the other side and divide by acceleration. Everybody agree? So we end up with T, and I'll put the 1/2 there so we remind ourselves this is just half the time, right? T for 1/2 the journey is just going to equal negative V naught over A. So what do we get when we plug in numbers then? We get negative 20.1 sine, I'm just going to call it theta, okay? Sine theta divided by negative 9.8. So the signs work out. We get positive, which we should. And what do we get for an answer then? That's just a calculator number. And so, pull up our calculator. So we get negative 20 times sine 51.9 divided by negative 9.8 gives us, how many sig figs are we going to keep here? 3, I think, wasn't it? Pretty sure. 3 sig figs.
Yeah.
Why is it negative? Because this is all equal to 0. So what do we have to do to isolate the t? We have to subtract that to this side and then divide by a. Right? Everybody agree? Okay, and so we get 3 sig figs to 3 sig figs. We get 1.61. Okay, so let's put that one in there. Oh, you're right. Times 2. Good thinking. That's the time to get up to the top. Man, I would be flunking this test today. So times 2. Times 2, so 3.21. Very good, very good. 3.21. Seconds, right? Got to put seconds in there. So the football travels a distance of what? All right, so we figured out what the hang time was. Now we can come over to the boring horizontal motion, and it's just constant velocity. If I want to find out how far it went, what do I need to know? Just time, right? So time was roughly equal to then, what was it, 3.21?
So isn't it just velocity times time?
That's it. Velocity times time, right? So if we want to find delta x, it's just v sub x times t. And so I'll just put in those calculator numbers and get an answer, right?
Yeah.
Right? I won't even do it. We could all do that. And then last one is football reaches a maximum height of what? So now I got to go back over to the other column. What am I going to do?
Just use equation.
Yeah, I could just use equation 4, or I could use this time if I wanted to, right? That I calculated the time, just half of the time to the top. But I could just use equation 4. I don't even need the time, right? Why not do that?
Could you use equation? No, you couldn't. Could you use equation 1?
You actually could. You could. That'd be tricky. How could you do that? It's good.
You would have to do half
Yeah.
of the time.
Yeah, because the
Half the
average,
velocity.
half of the velocity, the average velocity would be halfway between your starting and 0, right? So you could just take half of the initial velocity times half of the time though, right? Not the 3.21. It would have been the, what was it, like 1 point something, right? Yeah, right. It's on our calculator. Or if you want to just play it safe, you could just do this bottom one too, right? That would be fine also. If I use the bottom one, for example, what's that going to look like vertically? That's going to look like v sub y squared minus v naught sub y squared equals 2 a sub y delta y, right? And the initial or the final velocity is 0 on the way up. So all I'd have to do is just divide both sides through by 2 times the acceleration. And so this is going to be equal to the vertical displacement, isn't it? Right?
Is it still negative?
Yeah, it is, because that's negative, right?
Oh, yeah.
So if I plug those numbers in, what's that going to look like on the calculator then? It's going to look like, okay, I'm going to use the fraction template, how about? So it looks a little bigger. Or so I can see the top and the bottom. That's a common mistake. Ian made that mistake earlier. He divided by, and it's so common, like he would have done something like this. Let's not use it. if we said negative V naught sub y is which one? That's the sine one, right? So it's this number. Gosh darn it.
When the whole screen turns blue, it's about to do that.
Yeah. So it's that number right there. Everybody agree? That number squared. There's my negative V naught squared. Divided by, now here's what Ian did. He divided by 2 times a sub y, which is negative 9.8, right? What's wrong with that? Didn't put it in parentheses. So what the calculator did there was it divided that number by 2, calculated an answer, and then multiplied the result by, instead of dividing by negative 9.8. So I'd have to go back and put that in parentheses, insert, whoops, not that. Have to go back and change that to, there we go. Oh, what's that?
Times.
Well, it's a time. So second, insert, 2, that's right. 2 times, and then I go over, close them, like that. Okay. That doesn't seem, that's not right. Oh, I picked the wrong number. What did I do? Oh, I never figured out what 20, okay, I see what I did. Oh my gosh. That number right there, the negative 1.6, that's not the right number. That's divided by negative 9.8, right? Oh my gosh, this is, I'm screwing this up so bad. So if I just go back and edit this, here, let's do this. We're going to go back, and I'm just going to use V naught sub y is just 20.1 times the sine, right? So we'll just make it that. 20.1 times sine 51 point, oh my gosh, 0.9. And then I gotta delete. Did I forget? Oh, there's no 1. I got you. Okay. Oh my gosh. So frustrating.
It's rain. It's throwing you off.
Yes, yeah, maybe that's it. So everybody agrees. So there's 20.1 sine 51.9. So that is my negative V naught, right? V naught is just, sub y is just that 20.1 sine 51.9, the initial y vertical component. Agreed? Square that, multiply the whole thing by negative 1. Now this should give me the right answer. Okay, why is that so small? Oh, because once, God, you guys see what I did wrong? I see it. I did negative 20.1 times sine of 51.9 squared instead of doing the whole thing squared. My gosh. Okay, if you've lost all faith in me, I would not blame you right now at all. Okay, there, that's better. Okay, that's what we want. All right. If I just plug all that stuff in, so we get 12, what is that, 12.8 meters. Okay. I'll let you work. Get questions answered before I screw something else up. I'll put these numbers in here. So 12.8 meters. Travels the distance of. I'll put these in there so in the notes you can check this if you want to like redo this problem or something. So delta x is going to be v sub x, which is this.
She says it, OCN. She doesn't type.
Times t is 3.21.
Oh, my dad does it too. Yeah.
Yes. Okay, I quit.
Are you done?
I'm done.
Oh, if you can quit, we can quit.
No, not true. Not